Oh, good morning, everybody, and a warm welcome to all of you on yet another edition of #BMT Experts, where we bring in experts from around the world to talk about what's happening, in the latest space of either bone marrow transplant or stem cells, or the new kind of generation medicines that are coming out. It could be immunotherapy and stuff like that. So I'll just give you a little bit of background about Bone Marrow Transplant Support Foundation. We formally started this organization about 3 years ago, and I'm happy to announce that we completed 3 full years in March, supporting patients all over the country who are undergoing bone marrow transplant. And we also had some from Australia, Bangladesh, Nepal, and Pakistan who we supported during this process. So it's been an amazing journey so far, and so many of them have contributed to kind of making this happen. And what we realized during this process is education for the patient is extremely important, so that we kind of arm them with helping them cope with what they have in store during a bone marrow transplant. And it's a tough journey. Bone marrow is not going to be an easy process given the fact that it's a stem cell transplant. However, I think more information on health, diet, nutrition, understanding what a bone marrow is, what to take care of during hygiene and stuff like that, I think that are extremely important. And we've been supporting, through this process. So as a part of our entire education in the BMT expert space, every month we invite an expert who's had a global experience and who's been really thorough in their work that they're doing as far as research, orientation, right there in terms of latest technologies and processes, so that the patients are able to take an informed decision about their health, about their life, about their, about their treatment options and so on and so forth. So I'm very happy to invite Dr. Subhadra Dravida today on the call. I think she's a phenomenal person. And let me just give you a little bit of the background of her illustrious career and who she's an individual before we jump into the call and hand over the dice to her. So she's the founder, CEO of Transcell Biologics Private Limited. And she's always been in the space of innovation in healthcare, biotechnology, in India and abroad. She's an entrepreneurial technocrat of global standing in the domains of stem cell technology and product development. She's a PhD in stem cell biology and in the clinical informatics research, having associated professionally with organizations like UNC USA, OHRI, Canada. She has peer-reviewed publications, and probably for the first time on our #BMT expert, we have somebody who holds patents to her credit in this space. And apart from that, I'm very curious, and obviously we'll come to some questions about her personal self and her journey, given the fact that she explores monasteries and reads science fiction. So, that or a little bit of curiosity. So we're going to come to that question at some point. But really, so happy to have you here, Dr. Subhadra, and welcome to you on the show. Thank you so much for being here.
Thank you, Neeraj. Such a lovely Sunday to begin with, having this opportunity. So you had given me one topic, and then I prepared some slides as well, to make it a meaningful interaction. So should I share the screen and then go about talking?
Yeah, absolutely. That'll be lovely. In fact, I've already given you the option to share screen, so please go ahead.
Okay. Okay, I hope the screen is visible.
This is very clear. Thank you.
Lovely. Okay, so good morning and a bright, beautiful day for you all. In fact, in Hyderabad, it's one of the bright Sundays, we seem to enjoy. Before I jump to the topic of health indicators using predictive testing that Neeraj has commanded, that this should be covered, I thought I should set the context by speaking on cell and stem cell informatics, genomics, a little bit of molecular diagnostics, followed by introducing the concept of predictive genetic testing. So this is my agenda for the next 15 to 20 minutes. Neerav?
So absolutely beautiful, beautiful.
Right, great. So, see, genes are inside almost, every cell in our body. Each gene, contains instructions to our cells to make proteins, while proteins are expected to perform all sorts of tasks in our cells. There are about, 25,000 genes in the human body. If I have to tell you about the genetics of cells, which is important in terms of understanding the relationship between, the fundamental unit cell and then the entire field of human genetics. DNA is the cell's genetic material present in chromosomes within the cell nucleus, and the chromosome contains many genes. Sometimes DNA, is known as a molecule inside the cell that contains genetic information responsible for the development and function of human body. This is the molecule that allows information as well to be passed from one generation to the next. So in essence, cells are important units in human genetics as they provide structure for the body, not only absorb nutrients from food, but also convert nutrients into energy to carry out functions. Again, precisely kind of state, cells contain the body's hereditary material and can make copies of themselves. Yeah. With that basic introduction, connected to genetics, I want to touch upon a special category named stem cells. There are cells and there are stem cells. And I'm pretty sure, you all must have heard about, this term stem cells in the news, or from your doctor, or from your, communities, social, or in fact, academic circles also. But mostly for treatment options, I'm assuming. But I want to bring a different angle here in understanding why are these stem cells different and important as well. Okay. See, in fact, stem cells are mother cells that you should know, from which all other cells with the specialized functions are generated. Under the right conditions, either in the human body or laboratory, stem cells or one stem cell will divide to form a clone of itself and a specialized cell. So this is how replenishing happens, while adult stem cells are always found in circulation as long as, human heart continues to beat. So I just want to stress upon here the fact that stem cells are the origin for life and are continuously replenished in a healthy body, since they are the origin, or source for all the other specialized cells, like, let's say, epithelial cells or RBCs, neurons, bone cells, etc. The genetic information coded in the stem cells is comprehensive and authentic like mirror. So this is the punchline here in my, the entire presentation. Emergence of next-gen gene sequencing methods, advanced proteomic techniques, approaches continue to produce big data of biological informatics that captures molecular frameworks, underlying nuances of disease and healthy status. That there are, you all should know that, there are exclusive global data banks pertinent to stem cell research related to special genes, proteins, functions, signal transduction pathways, integrating analytics and specifications. So there is also a specialized and niche field named stem cell bioinformatics, generating continuously heterogeneous data sets, biomedical ontologies connecting to disease pathologies. With that background, I thought it makes sense to cover some of the key terms like omics, genomics, epigenetics, gene expression, that day in and day out, we use these terms in human genetics field. And you also must have stumbled upon, in somewhere or other, your daily conversations. Omics is not like, these are not omics, genomics, or epigenetics, or gene expressions. They're not synonyms, and they're not loosely used also. They have a special meaning and context as well, wherever they're used. So, for example, if I have to define omics, it's a comprehensive study of, it's a term that is used for describing the comprehensive study of biomolecules like DNA, RNA, metabolites, and proteins, which underpin, again, there is a link, which underpin biological differences between individuals and between healthy and diseased individual also. Yeah. So that is about omics. And then genomics is another term, which means study of genes, their functions, and related techniques. So there is a component of the technology and techniques as well in studying these genes. So that is what is called as genomics, while genetics is the study of heredity. You see, I want you to appreciate the difference between genomics and genetics. Although, it's not very obvious in understanding, the subtle differences. Yeah, so that's about. Then this epigenetics. That's also, one of the terms that I'm not saying that, it's loosely used, but it would be nice, if one understands, what is epigenetics. So it is the study of how our behavior and immediate environment can cause changes that affect the way our genes work. So there is this element of genes and then our behavior influencing the way genes work. So it's really beautiful, the definition and then the context of using these terms also. Lastly, gene expression. This is an important process by which the information encoded in a gene is turned into function. So the relationship between the genes and the function is what is defined as gene expression. See, I have an ulterior motive, for bringing all these terms, because by giving all these definitions of related terms, I'm alluring to the point that gene expression profiles of stem cells are authentic, original, not influenced by epigenetic factors, and so are the best bioinformatics platform for predictive testing. Because there are many approaches, there are many groups who got into this predictive testings, but then the source of information should be authentic. Say, there are ways to get information surrounding these biomolecules from, let's say, a differentiated cell type like epithelial cells or neurons or bone cells. But the gene expression or the gene expression profiles of those cell types would be, different from the kind of information that you can actually procure from stem cell profiles. Yeah. So that is something, if you appreciate, I'm sure, you are in a better position to even kind of question or interrogate all the data that is available everywhere, rather. Yeah.
No, absolutely. And I'd like to add here also, I think it's very important for everybody to understand that this is so different from a data analytics through artificial intelligence. So this is AI used very differently from the source of the stem cell based information. So it's not something that has any noise. So it actually cuts all the noise from epigenetics and the other factors and just focus on what is actually there as part of stem cells. So I think that's very critical, and thank you so much for bringing that up.
Yeah. Awesome. So although like my next slide, yes, I believe is on predictive genomics. Before I go there, I thought, it makes sense for us to quickly touch upon the basics of traditionally practiced molecular diagnostics field, because there is a reason why, one should understand the differences between the regular molecular diagnostics and the other new age technology of predictive testing. So what is this as a concept? Molecular diagnostics as a concept. It is a process of identifying a disease by studying, again, biomolecules such as DNA, RNA, proteins in a tissue. So it's actually, a very popular and established branch now, used to guide patient management from disease diagnosis to treatment, especially in the fields of cancers, metabolic disorders, infectious diseases as well, like, health conditions. And in this approach, in fact, PCR and RT-PCRs are like, highly popular techniques employed in diagnosis of the disease. And with COVID-19, pandemic seeping into our lives, everybody and anybody now kind of understands, like, what is this PCR and RT-PCR. It's amazing how the scientific knowledge and the technology techniques, like, have actually got into our day-to-day life. So here, the diagnostics is a test that helps to figure out what disease or condition a person has, but based on symptoms and signs. So signs and symptoms presented give clues to the doctor, who would then go about prescribing a particular test to diagnose the reason, or like, the indication behind the signs and symptoms. Therefore, it is the present condition that is diagnosed based on the information from the biomolecules which have started playing havoc at that point of time. Yeah, so molecular diagnostics or diagnostics actually depend on signs and symptoms that are presented. Yeah, so there is a link between what you actually present and then, like, the reason why a particular test is kind of prescribed. Now, having said that, as I promised, I would take a minute to speak on, the predictive genetic testing on the basis of, again, predictive genomics, this kind of testing approach, I think, is fairly new and pre-symptomatic. Yeah, so that's the difference between your diagnostic testing and predictive genetic testing. So it's pre-symptomatic and could be on the basis of, let's say, family history or any family member, suffering with any chronic disorder that has, again, genetics link as the basis. Okay, so these tests are essentially used to detect, first one, predispositions based on certain unique gene markers characterized as risk factors. So it's predispositions towards, a set of chronic indications, but then that should have genetics link also on the basis of, like, the genes. Or sometimes it could be detecting gene mutations that are known to be associated with certain disorders. Yeah. So in fact, here, even in predictive genetic testing, databases play crucial role to fall back in reporting. And most of the times in India, we depend on, the US population specific, well-established databases, though it's not aligned, given the deep differences in ethnicities, epigenetic factors, etc. But, that's the parity. Yeah, we just have to live with that for now, unless, like, our country kind of invests and not just investing, kind of come together, like, tying the dots and then connecting the dots with the everyday, like, whatever the data mining we do with the Indian population specific genetics. And we have to create a repository for ourselves, in fact, in terms of building or falling back on any knowledge and, databases for our own good, basically. Yeah.
Oh,
So,
absolutely. Even for HLA typing, I think
yes.
India has a huge issue in terms of number of donors being available, where other countries have extensive awareness campaigns that run throughout to kind of build this entire database. I think India is lagging way behind. But I think yes, I think through conversations like this is where I think the start of that awareness campaign, I think somewhere will kind of begin. But really, this is amazing and so detail oriented. I think we're enjoying this. So please go ahead.
Great. Yeah. Now, I thought, like, I should give some known, health indications that of late, like, which have benefited with all the predictive testings that we have undertaken. So cancer disease, which we all know is one of the most complex syndromes known to the humankind, is the best condition being benefited by all the predictive genetic testing approach. Again, among the cancers, breast cancer is a very well studied model where single nucleotide polymorphism and the gene variants detected predicts the disease occurrence with more than 90% accuracy. So it's important, like, we have this tendency to kind of brush off any advancements, by diluting the commercial intent and, totally underplaying, like, the science and, the technology aspects of it. But then if we can set all that aside, this is indeed, like, for cancer prediction modeling, we are rather, like, blessed to have all this literature available, and the clinical relevance also, is amazing. See, you have all kinds of information ready in front of you, but it is the intelligence and then the smart way of analyzing the data is very important. So after breast cancer disease model comes prostate cancer, and predictive genetic testing is mostly helpful in scoring the risks. Likewise, testicular, lung, bladder, head and neck cancers as well have unique sets of genes expressed that are clinically considered as risky markers in scoring the predispositions. Yeah, so that is something, we all should, because in India also, every family or even extended family, whether they have any basis or not, we are kind of experiencing a blast of all kinds of perturbations, to do with our health index. So it's important that we know where we stand, and it's important to know even our predispositions, so that we are powerful, and we don't become the victims of our own stupidity in front of the diseases like cancers. Yeah, so that's one condition. Then I chose diabetes, which is a metabolic disorder, as the second example model, and with the rising number of individuals affected, resulting into significantly higher healthcare costs of treatment, as we agree, with again, with every family member in India with at least one member, would be suffering with this condition. Yeah, so it's like, I think India is the capital for diabetes, world's capital for diabetes. So again, there are several known genetic and genomic clinical studies available as literature and benchmark database to identify genetic variants associated with the increased risk to diabetes. So this is also kind of fairly well established, and going forward, we would be bombarded with a lot of options, to either dodge or postpone the very occurrence itself. Yeah?
Correct.
Yeah.
Yeah. In fact, can you just go to the previous slide for 1 second, please? I think one of the markers that I see here is HLA-B. In fact, even for a stem cell transplant, we have, the alleles which are A, B, C, and then the DPQ and DQ and stuff.
Right.
So is that one of the similar markers that is used for, like when we do the HLA typing? Is that what HLA-B is?
It is, but for diabetes, it's not like a standalone marker.
Not like a standalone.
Combination of the other variants and gene markers, biomarkers, based on these, the scores would be generated in terms of predisposition.
Got it.
Okay.
Oh, thank you.
Yeah. So then the usefulness of genetic screening for lung disease risk is another hot topic, and is known to involve a combination of genetic risk factors that interact with environmental factors to cause disease. In fact, COVID-19 infection causing acute respiratory distress syndrome, ARDS, has opened up, the Pandora box of lung diseases linked to genetic predispositions also. Yeah, so this is another important model that is picking the attention and seriousness from the global communities. Having said all about cancer prediction models, diabetes, and lung diseases, there are more chronic conditions like neurological, cardiac, gynecological indications that can be predicted by gene variants detected. Yeah, so these are the other health indications, again, known to the humankind, that have link to do with the genes and genetic constitution. Yeah. Now, after knowing that there are methods to predict the predispositions towards certain debilitating diseases, one would definitely agree to this statement, right? Prevention is any day better than an expensive cure. Yeah. So
very expensive.
Yes, our focus maybe should be more on, knowing the predispositions and prevention than succumbing to the disease and going about like a cockroach, how to, address the disease indication that we kind of got onto ourselves, right? Yeah. Okay, now I thought assuming, I thought I would say this. So assuming that you got your, let's say, predictive test done, one could always argue that, okay, what next? How do we dodge or postpone the very occurrence itself? And it is the most logical thinking, because one side of the argument is, what is the point of knowing that, you have certain predispositions when there are not, I think, many options available, to treat or to address. That's a little bit of deviated or concocted thought process, but then there is some sense to it also. So according to me, the best and what is in our hands is to get the personalized nutrigenomics chart done for you. Yeah. So, and if you are wondering what is nutrigenomics science, it is the relationship between your genes and the specific nutrition chalked out to adopt, suggesting towards balancing the function to health index. Yeah, so this is also a new age science, while the technology depends on genomic sciences and, the data taking cues from personal epigenetic factors as well, essentially for lifestyle changes that have to be taken seriously. Yeah. So I thought this is low hanging for us.
Absolutely.
Yeah. Instead of asking for, your drugs or medicines day in and day out. I mean, for every 3 hours, we have to eat, right? I mean, we feed ourselves to keep going. So why can't we just focus on what is immediately available to us and then do the right thing? But scientifically, I mean, it should also be rather backed. Yeah. So nutrigenomics is something which is picking up and is also validating, because I'm one of the individuals, who got this done, and then I follow and I believe that, I'm good, and then I'm smarter than any, disease. That's what is my solace at this point of time. Yeah.
No, I'd like to take a detour here in terms of, nutrigenomics that you just mentioned, and just like to, I think, share with the audience. Last month, we had this call with Dr. Nikhil Phadke, and he brought out a very interesting anecdote there. He said they were researching a group of Polish town where everybody who was being born was an obese. And they were not able to understand, saying, why is every child in this particular hamlet, becoming obese? And then they were tracing back this using the same, genetic, inheritance, and they realized that their forefathers were those who were during the time of the Nazi invention, the Nazi invasion of Germany. They were kept in a camp and given such less amount of nutrition, food, sunlight, and everything, that their body had accommodated to live on absolutely scarce resources. Now, this happened 3 generations ago. And this generation started getting all the food, but the genetics had still thought that, oh, I have to live in scarcity. And every single child was being born. So when they solved the problem, they realized that, oh, it was due to a genetic inheritance, and therefore we could address. But I thought it's important to bring this out for the audience today of how important this nutrigenomics is. We don't know, because what we are caring and how we are caring from. For example, wheat, the maida, all the fried foods, nothing was not available in our genes 100 years ago. Where our forefathers used to have millets and healthy food and stuff like that. So since we have changed, has the genetics moved along with it, or do we need to make changes to remain healthy? So I just thought I'd take this 1 minute to add here the importance of this nutrigenomics that you just pointed out. And thank you so much for doing that, Dr.
I think rightly said, Neeraj. Rightly said. Yeah. So I run, as you know, I run this Transcell group from India. And, we have developed an offering named Pregen, which is built on primary progenitor cell-based genomics and validated bioinformatics tool for predictive health signature reporting that has personalized nutrigenomics chart as an addendum. Pregen is DCGI registered offering for India. To avail this productized offering, first step is to naturally enroll with us, followed by we arranging for sample pickup from anywhere in the country. It takes up to 30 days, to generate the report and deliver. Pregen is actually beyond just reporting, as it facilitates proactive cryo storage of healthy stem cells with Transcell for any future cell therapy requirement, as there is a saying and hope that, Neeraj, if any treatment should be there, it would be cell therapy approach only going forward. It is a profound statement, and, we all Transcell family members believe in this. And Transcell is, I am presenting Transcell should be your trusted partner, delivering on the promise of drugging the undruggable through cellular tools, So it's a humble submission. And I just want to conclude, Neeraj, by saying, may the force be with BMT Foundation and all the families, while Pregen can be your weapon to become immortals.
Yes, thank you so much. Yeah. We still can't see you if your video is...
just a sec.
No problem. Yes, thank you so much, first and foremost, so Dr. Subhadra, for this amazing, crisp, clear, fundamental presentations. And I think before we get into the audience Q&A, I have lined up a certain Q&A so that it gives a structure to the questions, that will emerge. First and foremost, like, for example, when in India, and this in context I can share very openly, in India, we have this process ki when a kid is born, we do it's what is called as a kundli. So we prepare like an astrological chart to say, okay, this is that. So, but in case of genes, genes keep changing, progressing as a person goes, or does that remain stable once a child is born and he's of a certain age, and after that you can say, okay, the testing begins at say 12 or 10 or whatever, and then it's like more or less predictive that way. How does this work in this scenario?
Right. Genes wouldn't change. I mean, genes would remain to be the same, but gene expression changes. And
Sure.
that's the reason why I brought, a gene expression definition into the context. And gene expression changes from, your time to time as the development goes on. And also there are differences between, the cells, which cell we are talking about, to look into the gene expression profile. But then genes are the same. I mean, you will be born with certain set of genes, and it can have, mutations, or like you will be born with, but then once after the birth, I don't think there would be any changes in the number of genes. Yeah.
Sure, absolutely. Because the question comes from the second cell is that cord blood cell is becoming a very valid way of doing stem cell transplant, at least in the other countries. And India probably has a lot to catch up in that space. But would cord blood cells also fall into this category where we can do the stem cell analysis of cord blood right there when the child is born and then kind of be able to give that report?
Right, Nirad, because see, cord blood is a biological discard, and if you have to source cord blood, you are not causing harm to anybody. I mean, the donor, cord blood belongs to the newborn. You're not touching the newborn, nor you're touching the mother. It's a discard, and we collect it from the cut umbilical cord tissue. Yeah, and cord blood is one of the richest sources of progenitor cells, and I meant all kinds of stem cells. So it includes blood stem cells, and the other cord tissue has mesenchymal stem cells, that give rise to the entire body. So it's the source, and accessing the source are key to the entire field in terms of harvesting the right kind of progenitor cells and then processing them for the intended applications.
Absolutely, absolutely. So that I understand. And so I think, so is not cord blood awareness also kind of had to be increased in India, where I think not only cord blood storage for any stem cell transfusion, and it could be community storage where if you don't need it, your child doesn't need it, maybe it will help for somebody else, or maybe those kind of rare HLA typing can be done for that. But is there not something that you think we need to work on the awareness of cord blood storage as well?
It's a continuous effort, Nirad, and it's actually part of continuous medical education. And see, it's not just the biobanks, but also community as such, including the clinicians and the practitioners at some point of time, have to believe the very purpose of biobanking and then the technology behind to address disease management and all. So it should be like an effort, but with inclusive of all these stakeholders.
Right. Got it. Oh, absolutely. So so I've just listed down some factors. For example, thalassemia and sickle cell anemia, is a big problem in India. So can, using the next gen sequencing, we can identify those particular biomarkers or those issues early on, if from the mother and father? Is that
Definitely,
possible?
definitely, yeah. That's the opportunity space, and yes, it's a possibility too.
So in case if a mother is pregnant, for example, and at that time, if we do this particular testing, is it possible to find out if the child is going to be a thalassemia major or not?
Possible to get the data, analyze it, and then
Yeah.
go about predicting. It is a possibility.
Okay, got it. In terms of the solid tumors, for example, say liver, liver related, say sclerosis or liver cancer or liver this thing and stuff like that. Are those predictions also possible through this medium?
Yes, Neeraj,
Yeah.
a lot of predictive gene markers that are known as biomarkers have been discovered, and these are completely unique set of biomarkers, and if you detect them in the sample, then the score is rather automatically meaningful in terms of predicting. Yeah.
Okay, got it. About eyes and lungs, we are seeing an increase in the eye-related problems or cornea, retina-related problems. And we know that epithelial cell therapy and stuff like that, it's still in the very, very initial stages. It's not been able to resolve so many of the issues. Can eye-related issues also, in the parents or grandparents, translate into some kind of a thing which a child could be?
So macular degeneration is one of the known, and retinoblastoma also. These are certain eye-related indications that have genetic link. So,
and retinoblastoma, is that something that can be rectified through like mesenchymal or epithelial stem cell infusion, through making drops out of those cells and kind of infusing? Because there's a new age technology that's coming in from where we make the stem cells, and using the stem cells, we make eye drops, and that eye drops helps to relate the problem and stuff like that. Is that a possibility that we can think of in the future? Maybe not now, but do you see a possibility of eyes?
Yeah, not retinoblastoma.
Not retinoblastoma. Okay.
Yeah, but the other, corneal regeneration and macular degeneration also. It is a possibility, especially if it is for corneal regeneration. Limbal stem cells are kind of considered as therapeutic options to regenerate. And then if it is for macular degeneration as an indication, some of the clinical trials are looking at mesenchymal stem cell therapy.
Fantastic, fantastic. So even IGVH would fall under that category, I presume.
Right.
Eye graft versus host disease.
That's
of
right.
the eye.
That's right.
That
That's
would also fall in. Okay. Now, like very simple question, allergies. I may have any food allergy or medicinal allergy or something. Does this report also bring out those kind of allergies that I should not be eating this, I should not be eating that and stuff like that?
Yes. Yes, that's the beauty.
Because that's a very important, I think, component of what people don't know, what not to eat and what to eat. And it's always an important question that's in their head saying, am I eating the right thing? Or some people get into this entire vegan now, this entire raw vegan, so many different types of, like the diet, the keto diet, this diet, that diet. So we don't know really what will work, what should, I should not have. So you're saying the nutrigenomics will very clearly bring out these are the expressions, and therefore you should avoid 1, 2, 3, 4, 5, 6.
Right, indeed, because let me tell you, from my analyzed chart, I got to know many things for the first time. Till then, I was under the impression that, I should be probably eating oats, and then can eat corn, and maybe like, the other health food, forgetting, bajra, is good, because in our families, like, with parents and all, they always kind of have been teaching us that, like, you should eat oats, you should eat this, that, and all. But then I realized that, like, I am not supposed to be eating oats, and should not be eating, should be eating less of corn, but more of millets. And, I should not be eating eggplant, although eggplant is my favorite vegetable, but then, like, kind of lessons learned from, my personalized chart. So most of the times, like, we kind of pick from what we are taught, or maybe by observing or looking at others, like, what they're following. But I think enough is enough. And then, like, we have to get our personalized report, and it makes sense for us to stick to what our genes want, or, like, would be suitable for.
Sure. Yeah, I'm already a little scared of thinking if my chart says samosa cancel, pani puri cancel.
No.
Okay.
Don't you worry. It is just a report. It's not a police.
No,
Yeah.
So, so another component is the graft versus host in the stem cell transplant, which is a big issue and a concern for so many people undergoing transplants. Do you think that we have already come to a stage where we identified biomarkers prior to going to transplant to see the possibility of what GVHD could come up? Or maybe a viral like CMV, or, something? Is that
question? Yes. See, Nirad, GVHD is like a storm, right? Cytokine storm. And this cytokine storm also has certain unique genes responsible for such a storm, So
I agree. So whose genes would you take? Would you take the genes of the donor or the recipient?
Recipient first.
Okay.
Yeah, because it is the recipient's body which is expressing the GVHD. Yeah.
Okay.
And the donors, whatever the cells, should rather, like, inhibit the storm that is presented in the recipient's body. So it can be managed if you know how would the recipient react, and then in terms of prognosis, like, there are certain markers that speak on the engraftment, as well as, like, the prognosis of the disease. It's actually
I'm going to take this offline with you, because this is a very, very critical topic, and GVHD is the biggest pain point of all allogenic stem cell transplants currently. So I'm going to take this offline, but now I think we'll open up to the audience for any questions. So in case if there's anybody from the audience who wishes to ask a question, please just unmute yourself, go ahead, switch on your video, and just ask the question, please.
Hi, I have a question.
Yeah.
So I have actually two related questions. The first question is that when you speak about pre-gene reporting, the one you said that, you get the report in 30 days. So who is the ideal candidate for it? And let's say if we take a lifetime of a person, we see that changes in our bodies happen at like 5, 15, 25, and after 35 or 45 for women when menopause kind of hits. So do I say that, as a candidate who wants to get this pre-genetic test done, it should begin when I'm 5 years old and repeated at these spaces again like a hemogram, let's say, not like so frequently, but after when I'm reaching those important points to see what is happening or what can happen, what would you suggest?
Good question, Sheetal. It is not supposed to be repeated, and it is just once in your lifetime. You can get it done just once in your lifetime. Because it wouldn't change, as I was talking to Neerath.
Right.
So it's your genes will not be changing. It's just the gene expression profile is different at different time points.
Okay.
And who is the ideal candidate for your question? Any health conscious individual.
Okay. So right from a kid who is just born to like a 90-year-old, if he wants to see what happened in my lifetime or going forward. Okay. And what would be the cost of such a test?
You want me to tell you now?
Well, some idea as to, if we, so where I'm coming from is that when you create an awareness in the community, and Neerath and I often come across patients who will want to know, or if let's say we want the registries to have more stem cells, or then it is very important for them to understand this, because India, as far as India is concerned, all the genetic related material is far expensive than what it is in the US. It's, for us, the translation is sometimes too high. So that's the reason this question. So you can give like a bracket saying it could be anywhere between this and this.
Yeah. It's between 25 and 30K.
Right. Okay. Yeah.
All right. I think
Thank
for
you
all
so
people,
much. Yeah.
For all people who've spent 30 lakhs in a transplant ever in their lifetime would value this much more than I think ever in terms of heart disease, where you end up spending 5 lakhs, or a diabetes where your lifetime cost is 50 to 60 lakhs, given the insulin that you have during your lifetime and stuff. So,
No, but Neerath, I would really take it as, along with your Kundli, also
correct.
get the test done.
Exactly.
It's the same cost.
It's exactly the same cost, because even astrologers will charge you, a good 10 to 11,000 for a Kundli and stuff like that.
So I have one more question, please. I'm really hungry for this. Early on in our call, we were discussing about how RT-PCR tests were being done for the COVID identification, and there were mixed reports or reviews about this RT-PCR, that RT-PCR only says that there is presence of a disease. It necessarily doesn't say that this is COVID, or it is a marker, or it will say that this is the state, but we don't know what that state is. So there were a lot of confusions about whether RT-PCR is a sure test for identifying COVID or not. But I think because of a lot of fear around it, people kind of started getting it done. And early on, the test would take at least 3 days to give a result, which was then becoming like, less than 8 to 10 hours. So what is true in this? Like, really, like, what is it?
So Sheetal, there's nothing wrong about the technique. RT-PCR technique is not a faulty one. It's just I'm sure with the COVID-19 virus that kept changing its structure, right? And so we had many variants. So to perform an RT-PCR test, what you do is you generate primers. Primers are the sequences of the virus, the viral gene. Yeah. So if the viral gene sequence is changing, the technique RT-PCR probably had limitations to pinpoint, whether the detection is made to the point or not. But as I'm just trying to explain, it is the infection or the virus which is at fault and not the technique, RT-PCR technique.
Right.
Can we open up to the rest of the audience in case if you have any questions? Yeah, the audience, this is your only time. It's very difficult to get hold of such an amazing human being, So feel free to ask any questions that you may have. Okay, I think the audience is still processing just so much of.
I have a
Yes.
simple question, like
Yes,
for
please.
layman, what is
Yeah.
stem cell therapy and when should one go for it?
Deepakji, that's a question that I think, we can take offline because that's what Bone Marrow Transplant Support Foundation, we do it,
Okay.
as a full-time thing. So essentially, for people, there are two types of stem cell transplant, just to give you an answer. One is autologous, which is from your own stem cells, the transplant is kind of happens. Or there is an allogenic stem cell transplant where you need to have a donor who will give you stem cells and through which then your disease can be cured. So there are essentially two types of transplants, and this is called as a stem cell therapy. Stem cell therapy is also increasing beyond transplants now to several different forums. But essentially, when we talk about blood-related malignancies in India, for which maximum stem cell therapy is used, then that is called as a hematopoietic stem cell transplant or a bone marrow transplant. And in this, there are predominantly autologous and allogenic. So this is the stem cell therapy that we are talking about, predominantly used in India for transplants. However, I'm sure, you can add here, Dr. Subhadra, stem cell therapy per se. What all can it be used for?
Okay.
See, there are many clinical trials going on for repair and regeneration. So under repair and regeneration, you have some of these indications like osteoarthritis and autoimmunity, and also to do with sometimes, there are a few clinical studies on diabetes also, and for cardiac ailments and for neurological ailments. So these are some of the other indications for which stem cells are being explored or clinically kind of studied for doing, repair and regeneration. Yeah, these are two terminologies. One is stem cell transplantation, and the other one is stem cell therapy, as Neeraj was trying to, get the meaning out of it. Transplantation is essentially for blood and related disorders, while therapy is for other indications, as I just said, for repair and regeneration.
And for thalassemia, you had referred to it, but not much could be understood.
So thalassemia also, there are transplants that happen now. If we find a full match outside donor. So it could be a donor from the family or it could be a donor outside of family. But thalassemia, usually people do it only when you have a 10-on-10 HLA match. And this falls under the category of stem cell transplant.
Okay.
Yeah. And we can talk about this. Deepak, you can always kind of, just message me and I think we can take this offline.
We have some good, publications, clinical publications to share on the options to address thalassemia, stem cell transplantation options. I will be happy to share with Neeraj and
that'll be lovely.
We can at some point of time, even just for academic discussion, we'll be happy to participate.
Oh, that'll be phenomenal. And I have a pain point with the stem cell therapy, actually, Subhadra, here. Because I remember I was in the transplant unit and they rejected my insurance because my doctor had written stem cell transplant and they talks I was undergoing a Botox treatment using stem cells.
Oh,
So the
God.
entire insurance was rejected for my bone marrow transplant. It's so funny. We couldn't get over it for the longest time, but they assumed that this was stem cell therapy. And I'm like, why would I go to a beauty treatment undergoing transplant? But that's on the lighter side of how insurance companies do not understand stem cell transplant, stem cell therapy, even till date today.
Right. They need to be sensitized as we were talking about, continuous medical education. Even, the insurance providers as well, are stakeholders here. And it requires a lot of, bringing them to speed with the advancements and then the applications, real advancements and applications.
Correct.
Yeah.
Correct. Lovely. I think we're coming to the end of the call. We're already, over the line. But just a final question that I want to get back, and I was very curious about your exploration on the personal side. We don't know personal, side of who Subhadra is. So I'll be very happy to understand your interest in monasteries, or is say Buddhism an aspect of your study? What's that part of you that we don't know about?
Right. It's not about Buddhism. It's about the architecture, and then to do with monasteries. Also, let me share. We have a place, a chalet kind of a place in Kullu in Himachal Pradesh, and just next to our place is this Kegampa, and Kegampa is a monastery over there.
Yeah.
So, and Dalai Lama also keeps visiting that monastery, and also it is to do with the place and with the serene atmosphere inside and outside, and then the way of their life attracts me, and I kind of relate myself and my life to the simple living to do with the monasteries and the monks over there also. It's really kind of how you put yourself towards attaining, let's say, inner peace is what would attract you to such marvels. So monastery is one, and then I'm also very curious to read the night sky. So that is another zone. One is monastery and the other zone is night sky, which is very mysterious. And then there is something it's not the darkness, but then the power from the universe is what I get from night skies. So one is inner peace from monasteries, and power from the universe to face the universe from night skies. That's what is me.
Beautiful.
So I have a teaser ending question. Do you see that there is similarity between life under the microscope and from the telescope?
Beautiful, Sheetal. Yes, it's all related in the universe. So life under the microscope, and then life, what you see through the telescope. Yes, it's all related. And then I see relationship as well.
Thank you so much, Dr. Subhadra.
Yeah, I think this is one of yes, please go ahead.
Yeah, my name is Mahesh. I'm from Pune only. So I have one question. Is there any possibility to reduce the HbA1c from 7? I'm a pre-diabetic patient. So is there any possibility to reduce the HbA1c?
So I think your question is about managing diabetes.
Yes.
Yeah. So I think for that, what Dr. Subhadra had addressed is, once we have the report, it will also give you an offshoot of nutrigenomics as an option, which will probably tell you what are the foods that you can eat, you should not eat, and and your predisposition to diabetes in terms of HbA1c 7 is almost like like 6 would be the borderline, and probably 6 to 7 is just about starting of this process. So early on, and there are also several other options which we can definitely discuss, but there is a group called Freedom from Diabetes in Pune, which works extensively about trying to reduce diabetes through lifestyle changes, food changes, and they very beautifully support patients to do this journey. It's called Freedom from Diabetes. Yeah, even if you Google Freedom from Diabetes, I think you will come to know of this.
Okay, fine. Thank you very much.
Yeah, but we can definitely discuss this, Mahesh, in terms of, on the Umid group as well.
Yes.
Yeah.
Thank you.
Yes, thank you. Thank you so much, Dr. Subhadra, for this amazing conversation, this beautiful, crisp outline of this entire, the health indicators using predictive genetics. I think this episode of #BMT Experts is really going to help so many people across the world to understand why it's important to kind of get this testing done early on in life, so that you can manage the rest of the life with ease. So thank you once again for this amazing conversation.
Thank you so much, Neeraj, for this amazing opportunity to connect with the BMT Foundation and the families. Yeah, amazing. I truly cherish this relationship that we have developed also, Neeraj. Yeah, excellent.
Absolutely. And look forward to many more meetings, many conversations, and my visit to Hyderabad very soon, hopefully.
Excellent. Take care. Yeah. Bye-bye.
Yeah. Thank you so much.